Welcome to my talk on No-Thigh Strengths, Comprehensive Dialogue State Tracking Diagnostics. My name is Justin Cho. I'm a USC ISI PhD student. This work would not have been possible without my amazing collaborators from Meta and Google. Dialogue state tracking is a slot-filling task of identifying what the user wants in task-oriented dialogue. If the user says something like, I'm looking for a 5-star hotel in Los Angeles that offers free parking, we want to extract this underlined information into a structured format so that we can pass it on to an API that will be able to retrieve information from a database, which will eventually be used to ground the bot's response. Something like, we found 2 options, the Four Seasons Hotel and Conrad Hotel. Which one of these would you like to book? As you can see, reliable DST is a crucial component for digital assistance. DST is evaluated using a metric called joint goal accuracy, or JGA, and it's used on an in-distribution test set. JGA assigns credit only when all of the slot values are correctly predicted. The problem with this setup is that JGA is overly simplistic and that it does not capture any of the fine-grained information about failure modes. It does not tell anything about whether the predicted slot values were not from the dialogue, which is called hallucination, and whether it has failed to resolve any co-references. By evaluating only an in-distribution test set, we don't have any information about their robustness. DST models are well known for their lack of robustness to various different perturbations, such as paraphrases, as the one shown here. This is not news, and a lot of previous work have done individual analysis that goes beyond JGA. For instance, Chan et al. Looked at very frequent entities and showed that they are overly predicted, while Heck et al. Found that models lack robustness to entities that were not seen during training. Liu et al. Found that these models also lack robustness to language variety. These kind of analysis is great, but the problem is that they are sparse and uncoordinated, making these kind of comparisons and analysis across work very difficult. Imagine instead if we had consolidated and comprehensive diagnostics to perform fine-grained comparisons that facilitate extracting information about robustness and failure mode analytics. Instead of the diagram on the left, which leaves a lot of questions unanswered, we'll have this diagram on the right. We will be able to discover overlooked opportunities for holistic improvements in DST models. We measure robustness with consistent JGA, which assigns credit only when both the original and perturbed samples are correctly predicted. It also quantifies well-known challenges and problematic behavior. Co-reference resolution skills are measured with co-ref JGA, which is simply a filtered JGA score for cases that require co-reference resolution. The same day as a restaurant booking should be resolved to Tuesday, which comes from our previous turn, and the JGA is only calculated for this turn. Hallucinations is measured with factuality, which measures the frequency of slot values that appear in the dialogue. We intentionally flip this metric in order to make it such that all of the metrics are higher the better. For instance, if the input was I would like to leave for London, but the model generated a prediction train departure Cambridge, we would subtract the score from the factuality. To illustrate the value of CheckDST, we apply it to the MultiWAS 2.3 dataset because it has the cleanest annotations and also co-reference annotations which we can use for co-ref JGA. We use perturbations with LEUG, which are provided by Liu et al. For using their test set that applied paraphrases and speech disfluencies. For unseen entities, we scramble the characters. Instead of using entities from different DST datasets as done by previous work, this is intentionally done such that there is no unfair advantage to models that are pre-trained with them. One of the baselines, Soloist, takes pre-trains with the Google SGD dataset, and therefore we did not want any of these information to leak in. We first demonstrate the usefulness of CheckDST by diagnosing 2 major classes of DST models. Span-based classification models, TripPy and ConvertDG, take a multi-stage classification and copy strategy to extract slot values from the dialogue history. On the other hand, Simpleton style generation models are the complete opposite in that they auto-regressively generate the entire slot key and slot value. Our CheckDST diagnosis with these two models reveals surprisingly that higher JGA does not correlate with higher robustness, and that both of these models actually have very clear strengths and weaknesses. For instance, the SCLS models, they attain better JGA and co-reference JGA. They don't hallucinate by design, and therefore are more robust to unseen named entities. However, we see that gen models are actually way more robust to language variety, such as paraphrases and speech disfluencies. This made us wonder if higher JGA does not correlate with robustness across models. Could it be the case that higher JGA does not correlate with robustness even within the same model? We value the same models with CheckDST throughout training to figure out whether this is the case. In this setup, we found that both model classes share the same trend in that training until convergence actually leads to less robustness. And for the generation models, surprisingly, even before reaching the end of the first training epoch, some metrics were deteriorating already and also very rapidly. These results encourage future work on few-shot and zero-shot approaches that require little to no fine-tuning. Analysis to automate. We also automate qualitative analysis to compare patterns of failure, and we find that while the SCLS and gen models share the same trend and drop in robustness by training until convergence, the patterns of failure are markedly different. For the SLS models, they entirely start to give up on prediction, so any entity name that was given will become none over time. However, generation models actually incorrectly copies the subsequence of original slot values, but they still are able to predict the correct slot type. Despite both model classes failing on perturbed samples by training until convergence, we argue that in this case, generation models are relatively more robust because they're maintaining their original prediction behavior. Lastly, we show how CheckDST can guide the development of a holistically improved DST model. We propose a simple but intuitive approach called Prefined DST to improve on generation models' performance. We pre-fine-tune with relevant tasks that target weaknesses exposed by CheckDST, motivated by the strong generalizability of T0 and FLAN. The main difference is that we take a more selective approach for the tasks that we pre-fine-tune with, and we also add a DST fine-tuning task. We include tasks such as paraphrase classification to help with paraphrases, Google SGD Dialogue State Tracking to give more exposure to diverse dialogue entities, Google SGD DST to give more exposure to various entities, co-reference and resolution tasks to obviously help with co-reference cases, and text-to-SQL to help with parsing, which also exposes more entities that should be correctly copied over to the generation output. Although the idea is simple, Prefined DST attains results that are better across the board compared to all generation models, and also the overall best well-rounded performance when considering all the previous baselines that we've discussed in this work. The results make a case for a promising direction for boosting both JGA and CheckDST metrics at the same time. In summary, the Dialogue State Tracking community was overlooking opportunities for holistic improvements because DST diagnostics that went beyond JGA and in-distribution tests were sparse and uncoordinated. And we propose using CheckDST to overcome this issue by providing a toolkit to easily measure robustness and compare failure modes. The key findings were that higher JGA does not necessarily correlate with higher robustness, and that training until convergence might actually lead to less robustness. Prefined DST, a simple yet intuitive approach, showed that CheckDST can serve as a useful guide that leads to holistic improvements that are made possible with pre-fine-tuning on a selective set of datasets and then fine-tuning on the Dialogue State Tracking task. That's the end of my talk, and please check out CheckDST as it is easy to use. It's also available as a PIP package, and please reach out to me if you have any questions about our work. Thank you so much.